Hello, everyone. Thank you for joining us today. My name is Clifton Beck. I'm the host of Did You Know, the ESCO HVAC show. So we meet every week to bring top industry professionals to teach us about the things that are changing in the industry so we have an idea of where we are going. So we've spent a lot of time over the last couple months talking about cold climate heat pumps and technologies that are coming to our industry. We've talked about changes in refrigerants, so we know that we're making some transitions in the HFC phase out. We'll be seeing more things like R32, R454B. We're going to have incentives coming through things like the IRA and other local jurisdictions that will encourage us to look at higher efficiency technologies, particularly in our heat pumps. So I have a great panel of friends of the industry today. So I'll ask each of you to introduce yourself a little bit and what your capacity is in the industry. Tom?
Okay, my name is Tom Grunstra. I'm the Director of Training for Fujitsu General America, and I direct the training. We help build training, and actually in relationship to this, we're currently releasing a cold climate heat pump training with our distribution and rep staff. Nice. We have one currently with NYSERDA that we are participating in the New York region.
Okay, very, very cool.
Great. I'm Jamie Kono. I'm a research engineer at Pacific Northwest National Labs. I'm supporting a U.S. Department of Energy program to build workforce in the HVAC spheres, specifically HVAC technicians that are prepared to do cold climate heat pumps, to electrify existing fossil fuel systems into heat pumps or into dual fuel heat pumps, and to promote stronger commissioning and diagnostic methods, especially using smart diagnostic tools.
Oh yeah, a lot going on.
Hi, I'm Christopher Diamond. I'm a senior product manager for the Northwest Energy Efficiency Alliance. It's a 140-member utility alliance in the Northwest. And my role within that organization is to find the technologies and the approaches to supporting the industry as we change from one level of efficiency to our future state of electrification or energy efficient heat pumps. I'm kind of the guy that's supposed to find what's new and what's cool and try to figure out how to get that into the market.
So thank you all for joining us today. So as you can see, the mission here at the ESCO Institute and HVAC Excellence is to make sure that our industry is prepared for the advancements that are here, the advancements that we will see in the future, and the ways that we can bring the technology into a industry that is up to this point not been as easy to deploy as what we would hope for. We look at this transition in other parts of the world and we see that the technologies have been around for a while. They've not really been adapted as fast as what we could. So now what we're seeing is, especially from being here at this wonderful event, one thing that we have learned is when we see the changes in equipment over time. You know, a lot of us have been in the industry long enough. We've seen heat pump technology that once it was deployed, we've seen a time frame where it wasn't as easily accepted, right? Didn't produce the heat capabilities that it could have if it was engineered a little bit more advanced. So as time progressed, we started finding new technologies. We have now gotten to a point where we have adapted many of the components of our heat pumps into systems that perform at COP levels much greater than we would have anticipated even 5 or 10 years ago. So system performance has really taken on a different avenue, and so now we bring all of our experts of the industry to talk about the way that we can deploy these things properly and ways that can improve the efficiency. So one thing that we were just talking about right before the show, Krista, if you don't mind, what ways are we seeing a deployment of opportunities, like say maybe through like the IRA, for people to look at equipment in ways that they can benefit from funds to move into that direction?
Yeah, so as I see, we've got kind of two different sources of where energy efficiency comes from, right?
Yes.
One is on sort of the equipment side, where typically the classic move is let's raise the HSPF or SEER requirements for our incentives, for our tax credits, and so forth.
Right.
And the other side is around design, adaptation, installation, and commissioning, those kind of components. And so
Field side.
both that sort of equipment and field side for utilities. It's a lot easier to give rebates. For government, it's a lot easier to give tax credits for equipment side. and it's a lot harder to try to influence the state of technical knowledge of the installation practices
Right.
and such. So that's the go-to. Let's find, let's just raise this year in HSPF as the go-to solution. And so what I've seen though is that we've got a 10-year runway now with a pretty substantial incentive tied to the Consortium for Energy Efficiency's top tier performance level.
Yeah, absolutely.
So that actually provides a really interesting idea, like, would you just want to go for a higher HSPF and SEER? Or maybe there's some other attributes about equipment that make it easier for contractors to deal with the equipment, make it more likely that it's installed in a way that's going to be operational, support the trainings that are out there already. And so that's what I'm, the guy trying to figure out what's new and what's interesting is I'm kind of looking for what are those underlying attributes of equipment that really have a profound impact on the installation side.
Exactly. Yeah, because now that we have to look at procedures, if we all go back to proper installation procedures, we have paths that work very successfully for traditional equipment. As we move into our new technologies, well, now we're looking at equipment, and all you have to do is walk around and we start seeing equipment that has self-diagnostic capabilities. In the past, we had to look at an installation based on a sequence of operation. We still look at an installation by a sequence of operation. Now, how do we properly validate that system's going to perform based on its OEM data? And that's been a little bit of a challenge in some aspects.
It's a big challenge because if you just look at the equipment today, you can't just sort of touch it and feel beer can cold,
That's
good
right.
enough, let's go,
I
right?
can't put the vacuum pump on while I'm at lunch and come back and
not
fire
gonna
this
work.
baby up. It's a little bit different of a scenario.
So there's a lot more kind of knowledge that's needed.
Yes.
And at the same time, we have a workforce that is sort of aging out.
Yeah, and disassociated from technology in some way, including myself.
Right, and so for those folks to take a new person and turn them into that ultra technology, how do you commission a variable speed machine under conditions that are
Right.
not the test conditions? You're going to have them open up their documentation while they're in the field and do an interpolation between a three-dimensional table? I don't think so.
Right.
We need tools that can do that. The challenge isn't so much that the tools aren't starting to show here and there. Fujitsu and others are developing these things for their contractors.
Absolutely.
It's how do we give recognition that's meaningful?
Right.
And it kind of, from where I sit as an energy efficiency guy, it comes down to three things. I need to know what's the general definition or specification, as we might say, how much carbon or energy or demand savings can be from that, and the third thing is, how would I know it when I see it? How do I
Right.
know
A piece
that
of equipment.
Fujitsu's machine perhaps has this capability, but somebody else's maybe not? We have to have a common conversation about what is that differentiates, one commissioning tool from another.
Sure. So here a few weeks ago, we did an analysis of just taking a bunch of different manufacturers and looking at heat pump capabilities at cold climate temperatures. Because there's a lot of questions. What are we talking about with the cold climate heat pump? What is the definition of a cold climate heat pump? Does anybody really know? It's one of those items in our industry that we don't have a specific definition. It's not, hey, at -5 we can produce X amount of percentage of capacity. It's not, hey, at -15, -30, whatever we set for that number. What we do set as an expectation is that it has a capability of performing at a certain level down in lower temperatures. And that's not always consistent by region. So making sure that we're selecting proper equipment, that we have equipment that is qualifying for things, especially through like Energy Star ratings, and that we're doing a proper installation and commissioning of it. Now, when we get into installation and commissioning, one of the things that we see is a transitional change just by walking around the floor. We're starting to see a lot more diagnostics on equipment, right? We're moving into inverter technology. We're using transducers, pressure transducers, temperature thermistors. We have the capability of getting some baseline data and doing analysis. But what about like an existing system, right? That's another discussion that we've been having with PNNL is, how do we validate that a system is being installed and commissioned properly? And so, Jamie, what have been some of the efforts we've been looking at for using other tools for doing that?
Yeah, so PNNL, especially my colleague, has been, who's at PNNL, has been working on promoting the use of these more advanced tools. So replacing your traditional analog manifold with a let me bring that closer, with a digital manifold, but even more so looking at wireless systems and wireless probes that can communicate with your cell phone or your tablet, some kind of application that lets you do, like you mentioned, a three-dimensional interpolation, lets you do that kind of diagnostics on the spot, continuously, often with better accuracy and a lot quicker. I've talked with some contractors who say it's a really powerful kind of system because you can spread out your experienced technicians a little thinner, because they can get a newer technician going with this equipment. As a proud millennial, I know that we get the apps, we understand the technology, and onboarding those younger technicians, knowing that they understand system diagnosis and commissioning, means that you're streamlining your processes. You're hopefully lowering the number of callbacks you get.
Yeah, absolutely.
And people have a much better time with their new heat pumps because of these better commissioning practices.
Exactly. So, we're promoting transitions into our equipment using either equipment that has better smart capabilities, tools that we can add, which if you walk around, it's another thing we see a lot of, right? That's a transition our industry right now is into a lot more smart diagnostic tools and the software that has the capability of doing system analysis. So Tom, when we start talking about how that side of our industry has changed, if we talk about, let's just say, Eugene and I was talking about how mini splits, when he came here, how many years ago Eugene was the first one? 35 years ago, right? We were still talking mini splits 35 years ago, right? We were just talking about a different generation of equipment and capabilities. So as we have progressed, and particularly these last few years, how has our equipment and the technologies behind them really started to advance?
So it's a good question. And one of the things we have now that we didn't have in the past is the cloud.
Yes.
And so I can take my cell phone and I can go to an app.
Yeah.
And I can go and look at the status of a Fujitsu unit. Sorry, I'll try to get off a brand.
Oh, no, absolutely.
It's in my house.
Sure.
And I can adjust it, set a schedule for it, and that can even have a adaptation so that can send data to my contractor. So it's very possible for the very things you're talking about wanting in the future, those are in production. Those are in development, some really neat, fancy stuff. We, for instance, have several controls where from the control, the contractor has a capability of seeing the pressures, the temperatures,
remote
right
diagnostics.
On the control in the room. Now, it's protected from the homeowner typically because you don't want them to have too much information because that can be dangerous.
Oh boy, we've all had that engineer.
But the contractor has the ability to be able to see that data right there live. And as well, the cloud apps are in a neat development stage right now, and there are levels of access to that. So that the very thing you're talking about is possible, but you don't need to be there. Right? You can be anywhere.
So Tom, let me poke at that a little bit because what it sounds like you're talking about is sort of thermostat engagement. And that's one level of cloud engagement that it's the homeowner's experience, right?
Sure.
There's another one, which is the contractor's side, where they get to a site and they want to...
Remote analysis.
It might not be remote. I mean, honestly, you don't necessarily want to have everything connected. Maybe you just want to know when you get there, you slap on a couple of your tools, look at your app, and you get a diagnostic. That's a different deal.
You talk about a digital gauge set, and you want to hook that up to a modern mini split. You're talking now. We're talking inverters. We're talking especially the cold climate ones, which are the ones that have the most advanced features, are the most efficient, and can typically heat to the lowest temperatures. Those are the ones that are more complicated. You're not going to be able to take a superheat and subcooling. You can try, you can take one, but it's not meaningful to you.
Exactly.
Right? You can't charge by that, and you can't know you're charged by that. So you're right. Diagnostic tools and capabilities are important. But if they also follow the, going back to that installation, a proper installation, properly done, you're going to have a airtight, seal-tight system, right? Clean, dry, and tight, and you're going to look for that capability to have been done right the first time, and typically you have a very reliable system. Now, when it does go bad, when something
Then what do we
does
do?
go
What's the
wrong,
next steps?
that's what we have training for.
Exactly.
That more often than not, it's not a refrigeration problem, it's an installation problem where something was improperly sized, improperly connected. It's a very common issue. One of the trainings we have that's the most popular is actually, we try to positively focus it. What are the top things that go wrong on an installation, right?
Yeah, absolutely.
And that's our most popular training in our online learning academy,
Sure.
as well as for our reps and distributors to teach. Because, the guys laugh at it. It's funny stuff, but
Right.
we all make a mistake. If you have to hook up a set of wires and you cross them between indoor and outdoor, it doesn't work.
Right.
So
right.
a diagnostic tool can't find that. We still have to have people
in the
that know
field, knowing how to read the data.
that, right.
Yeah, absolutely.
They have to read the instructions. They have to take the training to learn how to work on a high-tech product. One of the goals of training, we talked about this yesterday.
Right.
One of the significant goals of training is take away the fear of a high-tech product.
Oh, absolutely.
It's
like
not
that.
just how to fix it, it's how it works, how it knows what it's doing. We talked about sequence of operation.
You betcha.
It doesn't have a traditional linear sequence of
No,
operation.
that's been the shift that we need to pay attention
so
to.
that's the training that we need, and
It
it's
is.
you talk about three-dimensional.
Yeah.
It's multi-dimensional.
It is
and it takes an
multi-dimensional.
understanding of how the product works. It's not an if-then, move forward.
Right. If you think back about sequence of operation, like most of us that have been out in the field, so many of us that are now teaching the sequence of operation of traditional, I would consider legacy pieces of equipment, it was very linear. We would start from A, we can work through a sequence of operation. If we had a wiring diagram, mechanical diagram, we can walk through the entire sequence. We would end up with some kind of a fault. So typically we started with some input from our homeowner, which may or may not be correct.
It's a thermostat.
And then we're going to hopefully start back at ground zero, and now we're going to do our sequence of operation until we get to a place that we're ready to find some type of a fault, and then we're going to go into diagnostic mode. Where we see the real transition now when we start talking about equipment that has onboard diagnostics and has capabilities of finding faults based on inputs, because now we're talking about a processor. It's not like we had a linear sequence where the output, say if I started with a call from a thermostat as an output, that is now an input for the next stage of the process. And we go from one output to one output to one input through our process. Now when we get into this technology, we're talking about multiple inputs, all being utilized by a processor that could be using those inputs for different outputs. So the linear progression of diagnostics is very different than the linear style that we grew up on. So it's a multi-directional sequence. And the beauty of having our onboard diagnostics equipment is that maybe that technician who's very tech savvy walks up to a piece of equipment, especially a cold climate inverter, and now he has a starting base of a diagnostic error code based on values off from our inputs. So now we have that opportunity to adjust the amount of time that it takes to get through homeowner's input, get through sequence of operation, find a fault. Now at least we have a starting point where we have data that can get us to our diagnostic portion of it much faster. So the technology is really an advantage in our industry when we look at the savings not only for energy, we look at the savings that it is putting on our workforce. Because now our workforce, we all know we're in a labor shortage. What if we get to the point where our technicians, who are very tech savvy, are able to get to that piece of equipment and get to the diagnostic side faster? If we eliminate 15 or 20 minutes on that call, get into that diagnostic mode, now we have the ability to definitely have a technician that knows how to go through those diagnostics for those troubleshooting, but at least get to a point where they understand what has happened to the system faster. Then we add cloud technology, man, now we're getting
So the
somewhere.
nice thing is that cloud technology, as it's progressing, has the capability of having contractor access remote if the homeowner allows it.
Right, yeah.
The contractor can see that data remotely from their devices
Absolutely.
that the homeowner can't see.
Yep.
So there are levels of the cloud now as it's developing where those processes are more visible remotely.
And the
that's
data's
neat
available.
new technology.
It really is.
So how quickly do you see this becoming ubiquitous within your product line maybe?
Ooh.
as new product is developed, all of our products that are coming out on the residential side, commercial is a whole different bird because it already has.
It's already there.
Yeah, right.
That's what everybody didn't realize. It's not like we're inventing our industry. We are utilizing tools that we already have in our industry, and we're bringing it into a
bringing
different
them into
environment.
the residential market.
That's all that we're doing.
So the tools are there. They're being integrated at today.
Yes.
This is not years down the road. This is months down the road.
Yeah.
Yeah,
It's
and
now the acceptance by the homeowner to actually have their contractor be able to reach into their unit remotely. I have one in my home.
Right.
Right, but
It's
I'm-
a sample model.
Is a
My
homeowner-
wife is afraid that somebody can see into her house. So we do have things we have to overcome.
Yeah.
No, but what I'm saying is that there is no remote, got to see it all time. It's only when the technician is really there.
Yeah.
I mean, you're not going to do a service call when you just get some little minor, maybe it's 5% less efficient. No one's going to roll a truck for that. It's when there's a really serious thing. You want to get out there and do that.
Absolutely.
At the point of commissioning, though, when we set the charge, when we set up the system, when we verify the ducts are intact and reasonable and all that jazz, that's pretty important. That kind of like
I agree.
basic information that feeds back to the contractor creates this sort of continuous learning.
Sure.
I'll make a statement here that's a little out on a limb here, but I'm going to say within 2 years, that will be an element of the tax credit requirements.
Ooh, now we're getting somewhere.
And of course, I've been on some of the panels
Yeah.
that have been a part of that. I've been also as a part of Energy Out West,
Yeah.
and working on some things where they had some programs and panels seeking to have that and try to say, okay, so tell me what your subcooling and superheat was on startup.
Sure, let's do a pre-evaluation.
How do you evaluate? So there's a lot of data that needs to be established of what those requirements are. I
Exactly,
agree.
and we're not talking about maybe the end of what's possible. Let's step into this
What's our
game. Like,
realistic-
what's the
what
next
can
step
we
of
Yeah, I
like,
agree.
so that we start conveying to the industry and to consumers when you want to go out and you want to buy a tax creditable, an Energy Star threshold or Energy Star most efficient threshold. That's really all the homeowner needs to know.
Exactly.
They're not going to have the contractor seeing what the room temperature is in their bedroom.
Right.
They're going to just simply know that the contractor can commission with advanced tools.
Yes.
Yeah.
And when they leave, whether or not they want that extended service contract where there is a 24/7 view
Yeah.
is up to them. But it's the starting point of this conversation of feedback to the contractor.
Yeah.
And that's why I'm really bullish on this idea that within 2 years we'll see some component of that added to this tax credit. And that will diffuse this more, that'll get more uniformity.
Sure.
Possibly we start, as Clifton was saying, sort of like having the OBD2 equivalent of...
Why don't we? I'll be the first one
right,
to say it.
go
I mean,
for
we've
it.
all seen what happened in the automotive industry. We all started using communicating technology. We had one manufacturer saying, well, let's just do this one, use this control. We had other manufacturers say, let's do this, just use this control. And then eventually down the line, we all got to a point where we all said, hey, you know what? Let's make it easier on the service technician, and let's help that service technician understand what these inputs are. May not be a diagnostic, but at least let's get these inputs into the hand of a technician so we have a universal understanding. Oh boy, I wish I would have a...
Yeah, you
I
think
would
every...
say within 5 years, but I'm not going to go down that
I'm
road.
not sure. I'm not sure.
Yeah, I hear. The brain
wheels-
is spinning on all the things that people are going to
Sure.
say in the manufacturing. end
Oh
of that.
boy, I'll get some emails over that one.
Everybody wants their own little private playground, their own little private garden where their contractors are the best, and we have the best tools. Come be part of our community.
What if we say that everyone has the opportunity to have installation and commissioning data on the startup of an inverter piece of equipment, and that can be in a centralized place, so that any technician has the opportunity to utilize that data?
Now, commercially, of course, commissioning, that is what's done.
That's
and
what
it's
we do.
being with all VRF systems I know of, it's done in an electronic
startup.
digital format,
Absolutely.
right? So it's not that far out of line to expect there to be a certain uniform setup
Yes.
and standard for that startup, right?
Yep.
There's no reason that couldn't be. At the same time, since all the softwares are different and they all communicate differently, it's
Yeah.
going to be a challenge to try to make that one device. It's a cool idea, but
Oh,
it's a
Yeah.
stretch to try to go that way.
I'm with you, Tom.
But
I think
I
that
like it.
I think you're already dreaming out farther than we can see.
That's all right. That's why we're here.
I do want to add, though,
Yeah.
that it's not just about looking into the future of equipment that's coming out that will be enabled with these things that we have separate diagnostic tools right now that are connected
Then we can do a lot of that with.
you can get a lot of that information with right
Absolutely.
now,
Data,
and is,
yes.
is really well integrated, I believe is part of some of this Energy Star quality installation program.
Yeah.
And so this is completely separate. So if you're a technician or a contractor working on systems that you've already installed,
existing
and they don't
systems.
have those integrated diagnostics like you were talking about, Tom, that you can still do that same diagnostic process. Or if you're working with one unit that you've always had, it doesn't have those onboard diagnostics, that's totally fine, because there are other tools that you can get that will not only let you work on your favorite systems, but also for any
Existing
other
systems.
existing systems that you go visit.
Yeah, and that's been a huge change for us, is the advance of technologies.
We're basically talking about coming up with criteria, right?
Yeah.
And you have coming up with established data set that will help establish something. So currently, again, jumping into, because I'm from New York State, I'm in the NYSERDA program. NYSERDA already has this established, and so are other states.
Yes, it's starting to
and
be
it's
very
being
well
done
adopted.
state by state.
Exactly.
So there are state opportunities, and then there are federal opportunities, and
Very
then
different.
manufacturer opportunities,
Sure.
right? So it's a matter of picking that data that's required for in commissioning.
What do we
and calling it
consider baseline
commissioning is
data?
fine. Data on startup.
Exactly.
Yeah, this sort of parallel path of the contractor training resources, the VOTEC, going in parallel to the equipment development that
Yes.
provide the tools. And then why I'm kind of bullish on this idea of there'll be some criteria in the tax credit. This is really about, this is what I'm doing right now.
Yeah.
This is what I'm working with P&L and others across the country to bring the evidence to those that are deciding what is the criteria for
What's
the tax
the
credit.
expectation? Yeah.
And we have to come up with a specification. We have to show that there are carbon or energy or peak demand
What's the
savings.
benefits in this?
And ultimately, how would I identify it in the marketplace? How do I know that, the Fujitsu version qualifies and some other brand has some work to do?
Yeah.
And we start baby steps so that we're not like just creating a barrier to entry. We start by inviting them to participate in this conversation around how do I help provide feedback? And
Yes.
that is actively going on. Having lots of conversations around the AHR show confirms that people are leaning in. They're seeing this as an opportunity, as contractor engagement, as distributor engagement. I think it's a tsunami coming.
Oh, I
Yeah.
do too. I mean, that's part of why we have these conversations. It's because this is real. I mean, this is where our industry is at right now. We have the capability too. And so we're seeing a lot of these different avenues all coming together at the same time. One of the questions that we've had in some of our previous conversations with the IRA is how are they going to distribute those funds? That's exactly what we're talking about. What equipment is going to fit that bill?
Yeah.
Who's going to hold that? So currently, what is our standard for what we would consider our IRA acceptable equipment? Do we have things that we have found, places that we're homing those model numbers?
Yeah, I mean, HRI is going to have their database that'll identify which ones qualify for the tax credit. Their database is still not populated, I guess.
That's
would
where I
say.
was going with
The database is still needing some work.
Yeah.
From what I've heard, it's months out before that's fully populated.
Sure.
So
There's a lot of
there's
stuff
definitely
out
a little bit of growing pains here in this
Yeah.
first year, and why this initial year of tax credit threshold was set very simply, not very complex. There is a cold climate and there's a climate classic. I don't know what you call it.
Yeah, absolutely.
And then what is cold climate? That was where you started
That's
this,
it.
because
That's a tough
really,
definition.
what is cold climate? Because and we talked about the weaknesses of some of the traditional heat pumps in the South when they
Yeah.
had a cold snap into the 20s and teens, where traditionally they never had that cold of a weather, so they didn't have electric backup, and the traditional heat pumps with older technology could not maintain
Not even
temperature in this
possible.
space.
Exactly.
Whereas mini splits for years have been able to ramp up when it gets colder. They don't put out more capacity until they need to. And so where do we draw the line for when that's good? Is it the lowest temperature? Is it -15, putting out nameplate capacity? And that's the problem. It isn't just manufacturer. It's the specific model that's selected.
Yeah, having coming from the 4 Northwest states, we have some of our funding utilities, their design temperature is minus 30 degrees Fahrenheit, and then others, their design temperature is 25 degrees Fahrenheit.
Exactly.
Right.
And I talk to the Montana folks all the time, and my definition of cold is not theirs.
No, that's it. When you look across this country, what is
I'm
cold
like,
climate? Well,
yeah.
what's cold climate in Florida? What's cold climate in Georgia? What's cold climate in the Northeast? And
It's the
Northwest?
Mason-Dixon line. That's what I've been told for years.
Sure.
Yeah. So another one is sort of like the basic criteria for cold climate is a COP of 1.75 at 5 degrees Fahrenheit. That means
There's
it's
a good number.
It's a relatively efficient machine at 5 degrees
Absolutely, very
Fahrenheit.
specific.
But within that, you can have machines that are 40% capacity at that 5,
Right.
or 100% capacity at that 5. And there's a big difference. If I said your heat pump is efficient, but you're going to freeze, that's not very satisfying to know you've got a cold climate heat pump.
Exactly.
So I've been heating my house, my homes,
Oh, this is a
with
great example.
mini splits
Yeah.
since 2007
Yes.
in upstate New York.
Right.
So I have some familiarity with it, and I have the brand who I work for in my home before I went to work for them.
There you go.
Is that the reason why you were hired?
Probably not. But it's a good story, though.
It is, and it's a very successful story, and that's why we're here. And that's why we do our show every week, to help bring our industry professionals to talk about these things, make it real, discuss that, not all heat pumps are created. I had to laugh when he was going through some slides earlier. I seen not all heat pumps are created equal. I'm like, oh my gosh, that's exactly where we're at. We have to know what we're working with. We have to know the capabilities, because there is some very capable equipment in our industry for pretty much all reasons, or all regions, and we're now seeing that expanding drastically. I mean, if you would have came here a few years ago, the low ambient heat pumps would have probably not been on the radar of most people walking around the show.
Right.
You walk around today and you go, oh my gosh. Everyone is paying attention now, and everyone is diving into the analysis of what that cold climate heat pump is, what the capability is it right for me, what's the incentives for doing this. So there's such wonderful discussions. A lot of good things that we can dive
So
into.
I'll do another little prediction here. I think
Okay.
in a
Oh,
couple,
I like that.
couple more years
Here
we're
we
going to
go.
come back. It won't be cold climate.
Yeah.
It'll be how efficient are you at mild climate. And some of the research we've
tell me more,
we
yes.
looked at is really showing that since the bulk of our heating hours is actually in that sort of 45, 50 degree
Sure.
range, for most climates, even the cold ones,
Yeah.
it's a lot of hours in that. How efficient it is, not when the machine's at max capacity, because you're not running an equipment at max capacity at 45
Exactly.
degrees Fahrenheit. You're running at minimum. So if you have a machine that is very efficient at low load,
Right.
low load efficient is what I'm referring to it, that actually produces more carbon savings and more energy savings. It doesn't address the peak demand that utilities face.
No.
You need a cold climate with capacity machine. But if you want to save carbon, you want to save energy, it's actually the low load and it's only possible with variable speed machines,
Yeah.
Correct.
where it's unloading, it's operating at its minimum fan speeds and the minimum
Capacities.
compressor speeds. That is a real opportunity. And looking at the data set that's out there right now on the NEAP list, the difference between sort of the bottom quartile and the top quartile is a factor of 2 at least.
Wow.
Difference in efficiency at that low load. So if you want to look at kind of what is going to shape the carbon offset and the energy offset, it's not actually do you have a cold climate, it's
Exactly.
going to be that. So we have not yet seen
Maybe
the
a new
buzz
efficiency
around
rating?
low load
No,
efficiency,
no,
but it'll
I
happen.
like that.
That's that modulating
Yeah.
the
down
modulating. All these
to
variable
the
capacities.
lowest. So today's equipment, the highest efficiency models,
Yeah.
they maintain the temperature by lowering their compressor speed, reducing the size of the orifice, changing the fan speed. And what you end up with is a system that's got a smaller capacity in terms of refrigeration cycle,
Sure.
but now has a larger heat exchanger. So now you have a much more instantaneous
Reaction time.
instantaneous efficiency that you're
Absolutely.
talking about.
Yeah.
And so as those units, if they're modulating, instead of cycling on and off with a thermostat, and unfortunately there's a trend of people wanting to put mini splits on a thermostat because they like their branded
Traditional, my legacy, this is
control.
what I've always done.
Right. And the problem is those typically limit that that unit
The ability
to
to
its
modulate.
ability to modulate. So that's
Absolutely.
also a step of what control is going to be hooked up to it, because if you want that modulation to work, it needs to be set up with a control that's native
Capable
to it.
to doing that.
So Tom, one of the things that I find really interesting about this low load efficiency is it really fundamentally comes down to, do you have some control over the metering device? and you have the algorithm within the machine to optimize that. And that typically means a communicating thermostat.
Absolutely.
But that those elements of hardware cost are pretty small. You know, they're not
Overall,
like a
it's not
phenomenal.
drastic.
It's not like adding another
Correct.
25%
Exactly.
area to your coils or your compressor.
No, because so you're talking about efficiency at part load.
Part
in terms
load
of how we
efficiency.
call it in
Yeah.
refrigeration, right? It's a part load efficiency, and so the less amperage that compressor draws, the lower it can run. You know, can it turn itself down to as low as 7% of its total capacity?
Which is amazing.
Right?
Where we've
when
gotten
we
here in
have
the
that
last couple of
capability,
years. Yeah.
we have those compressors that are fully variable. And again, as you said, without that electronic expansion valve, you don't have that capability.
No, absolutely.
And
You're not
then
gonna
the
do a
algorithm
TXV.
is a perfect word,
Yeah.
and that's exactly what it is. And it goes back to what you said about multiple inputs.
Yeah.
We're getting those inputs, and then it's making smart decisions and choices. Outdoor temperature, indoor temperature, coil temperatures, and then it's able to control itself, which is why we can't judge it by superheat and subcooling.
No, absolutely
or
not.
bare can cold.
Yeah, we have a learning curve that the entire industry is going to feel. So that's why we do these conversations, to bring the awareness that we are going through a technological transition in our industry. The technicians of today are going to be very different than the technicians of 5 years ago. Are they capable of doing it? Yeah, absolutely. We got the right people in charge. We have generations that know technology so much better than many of us that are already in the field working with equipment. So we're going to see that. We're going to see people getting smarter with the tools that they use. We're going to see people getting much more intelligent with the diagnostics that come on equipment. We're going to have better selection. One thing that I want to do is go back to one of the things that you brought up earlier was about NEAT.
Yeah, the NEAT database.
Jamie, would you fill us in a little bit on what we were talking about with NEAT?
Sure. Yeah, so the NEAP database is this database of air source heat pumps that expands upon the normal rated data points you get from the AHRI
Right.
rating system. So normally you just get capacity, COP at 47 degrees and
and
at
that's it.
17 degrees.
Exactly.
And you got, all you can do is draw a line from one to the other, and
Right.
that's all you got. And so that's not really
Comparable
that
data.
useful
Right.
when you're talking about these variable speed systems, about cold climate systems. So the NEAP database collects data from manufacturers that includes both the AHRI data points,
Yep.
but also data at 5 degrees Fahrenheit. It also includes min and max
Yep.
at that period, so you can see, what's the max actual capacity I can run the system at 5 degrees, and it will also let you enter the lowest rated temperature that the system has. So you'll have systems that can run down to -22,
That's right.
-15,
Not all
-5.
systems are created equal.
And yeah, and you can see it's really interesting to poke through there.
Yeah, it is.
This is definitely not what I do on my weekends for fun. Is you can see that some of them, like you said earlier, some of them at 5 degrees are at 100% capacity. Some are at 50%, and that's a huge difference. And depending on what someone needs, either one will be relevant to them. So it's a really powerful resource, and I think they've also, the last time I was on there, they had a little checkbox where you could that said TBD or coming soon
Sure, new
on
products.
federal tax credit
Ooh, alignment.
eligibility. So
Wow,
they're on
okay.
board too. So yeah, a great resource.
It is, and we're not talking about like 100 matchups. We're talking about thousands of equipment that are now having very, very good heat displacement at low temperatures. Gives us the opportunity to look at a unit and go, okay, if we talk about a heat pump, are they all the same? Absolutely not. Some of them shut off at 5. Some of them only go down 0. Some of them don't even like going below that. Some of them go way below that.
Some of them never shut off.
Some of
and
them
heating.
never shut off. And that's where we've gotten lost. How do we know without going through every single installation manual, looking at the extended heat data and going, all right, okay, this unit can go down this far. Nope, that's not what I'm looking for. Let me go spend another half an hour and I'll go find me another one. So now we're building a database that lets us go through, pick the brands that we're looking at, multiple brands, one brand, we can break them down individually by manufacturer. We can look at the specifications for the design temperature. We can actually go in and select, I need this many BTUs at this temperature. And we'll automatically start populating equipment that could be possible candidates.
So it's worth pointing out that this is free to anybody.
Free.
Yeah.
The data is, to a large extent, sort of extended capacity tables.
It is,
Not
absolutely.
exactly the same, not quite as detailed as the
Yep.
actual manufacturers.
Sure.
Tom, you're probably actually including in the training, they've got an amazing sizing support, an analytics tool built into it. So you can actually you can enter in your design load, and it'll show you how much of the year your heat pump will be operating in its variable speed range.
That's cool.
So what you're trying to do is you're trying to choose a piece of equipment so it's spending as much of its time as possible in that modulating range where it's more efficient.
It's maximizing.
And you're not oversizing, you're not undersizing, and it gives you a visual that I think everybody should go take a look at. It's really wonderful.
I did too. Jamie just introduced
Great.
me a few weeks ago. In the past, I have lived in my installation manuals because I only knew how well something worked once I looked it up exactly at its extended heating data tables. So now we can actually see those, we can compare them. It's a great resource for contractors, for technicians, for the industry to be able to look at it. What if you already have one and you go, wow, I've got this unit installed and I was told that it's a cold climate heat pump, but what can it actually do? I'll just hop on here, I'm gonna go grab my model, I'm gonna get my system matchup, and now I have an idea of what I actually have.
So in this next year, we're going to see kind of like that coming soon Energy Star. There'll be a coming soon connected diagnostics, low load efficient. There'll be other things you can filter and screen in this database to allow you to kind of look at other attributes of heat pump performance that are not just going to be simply HSPF and SEER,
Right.
but other interesting aspects. You know, a really good designer is going to look at all these things.
Oh, sure.
If they have time.
A really good designer. I like you said that because this whole thing has to start with the load on the space.
It does.
And that also then turns back to training and engagement with the contractors.
Absolutely.
And without that, they're not going to read the documents, they're not going to look at your website. So we all need to work to build that competency level.
Okay, lots and lots of great information. Any questions from anyone in the audience? Cold climate heat pump technologies, where the industry's starting to move to. A lot of things happening. All right, anything, anybody want to leave any contact information for the companies that you work with or any other resources before we leave?
You guys have the most important here. How do people access your site?
Yeah, if you want to find out more about what the Northwest Energy Efficiency Alliance is doing, it's neea.org. The database, which is our sister organization or partner organization in New England, is the Northeast Energy Efficiency Partnerships, or NEEP, neep.org.
Yep.
There's also a Midwest version. These are part of this broadly similar regional energy efficiency organizations.
Fantastic.
And of course, Fujitsu is fujitsugeneral.com. Will be a website to go to.
And while we didn't get in deep into a lot of other aspects of HVAC install, we do have a lot of resources that I work on at the Building Science Education Solution Center, which is a Department of Energy website. It's meant for educators and trainers, so it's got educational resources on heat pumps, specifically kind of filling in the gaps for technicians that are looking at expanding to cold climate heat pumps, looking at replacing fossil fuel systems with heat pumps. Great resource. And that's at bsesc.energy.gov. And a good other resource is the Building America Solution Center, which is a more consumer-oriented website, basc.pnnl.gov. And both really great resources for all stuff HVAC and buildings in general.
Awesome. And you can find us at escogroup.org. If you're on YouTube, you'll find us at ESCO Institute. And we're grateful to have the opportunity to broadcast here at the 2023 AHR Expo. And I'm very appreciative of my panelists for joining us today. Thank you, everyone.
Yeah. Thanks for having me.